Hello, in this example we are looking at decibels. Decibels are talking about sound. So we know that sound exerts a pressure P on the human ear. This pressure increases as the loudness of the sound increases. Loudness is measured in decibels, and pressure is measured in dynes per square centimeter. So it is found that each increase of 1 decibel in loudness causes a 12.2% increase in pressure. Because this function is changing by a percent, this is going to be an exponential function. So the first thing I want to just make note of is that I'm going to be trying to calculate an n equals p a to the t power formula because of that percentage change. Now, the first thing that it tells me that we also know that a loudness of 97 decibels produces a pressure of 15 dynes per square centimeter. We'll use that information, but not quite to start. First thing it asks me is to find a growth factor. So I see in the problem that this is an increase. That matches up with this idea of growth. We know that the growth or decay factor is this A value. And for a growth factor, I want to take 1 plus the percent as a decimal. So 12.2% would be 0.122. So my growth factor, my A value in the formula, will be 1.122. Then it asks me to find an exponential model for pressure as a function of decibels. So this means that pressure here is the output, or the Y value, and decibels here would be the input, or the X value, when we're thinking of terms of X and Y in a coordinate plane. With our formula for an exponential model, we use n equals PA to the T. N is the output, and in this case, the output is actually pressure. So I'm going to use P for pressure. P here in the original formula is the starting amount, and we don't actually know the starting amount. So I'm going to use the P and put a subscript of 0 to mean it's the beginning value. We figured out what our A is, so we know that this is 1.122. And typically the input is time, but in this example we have our input as decibels, D. So this is what my formula looks like in the context of this problem. I still need to figure out a number here as that starting value, but when I read the problem they did not give me that number. What they did give me is an ordered pair. So they told me that 97 decibels will produce a pressure of 15. So I can put those numbers in to my formula. So the pressure is going to be 15. I do not know the starting value of pressure. 1.122 is my growth factor when the decibel level is 97. So now all I have to do is the algebra to solve this out. And so the first thing I do is I take this 1.122 on my calculator to the 97th power. So 15 is the starting pressure, and I got a huge number here, so 70681.72195. Right? So these two, the value of doing this exponent is these two are multiplied. And so to figure out the starting value, I'm going to have to divide by that big number on both sides. Putting the dot, dot, dot there. Same thing over here. So on my calculator then I have P0, that's starting pressure, and my calculator gave me 2.122189, and then it had an e to the -4. So what my calculator gave me is a very, very small decimal, but it gave it to me in scientific notation. This -4 means I need to move my decimal 4 places. So here's my decimal, 1, 2, 3, 4 places. Fill in these zeros. So I find from that that my starting pressure amount is 0.0002. So after all that, I can actually write my model. So the pressure, the output, starts at 0.0002, and then it grows by 1.122 for every decibel. All right, so that is my formula that I'm going to work with. Next thing I'm going to do is this last question: when does the pressure on the ear reach a level of 200? So since that's a pressure, that goes into my formula for P. So 200 is equal to 0.0002 times 1.122 to what decibel level? When I look at this equation, the unknown piece is the exponent. So if I wanted to solve this by hand, I would have to use a logarithm, which is possible, but a lot of work. I can also solve this on a graphing calculator, though, by using a crossing graphs method. So I'm going to take this and make it to my y1 in my calculator. I'm going to take this formula and make it to my y2 in my calculator. So we'll switch to our calculator and look at things from there. So I'm going to my y equals, clearing out what I had previously had in here. So I said my y1 I was going to make to be the 200, and the y2 I was going to make my formula. So 0.0002 parenthesis 1.122 to the x power. So now I have to think about how to set up my window. So when I look back at my formula and I look at the ordered pair that it had given me a pressure of 15 when the input, the decibels, were 97. I want to get the whole way up to a pressure level of 200. So I'm going to have decibels that are considerably bigger than 97. Decibels, or that 97, is my x, and the pressure is my y. So I go to my window. My x is those decibels, which are going to be a lot bigger than 97, so I'm going to try going up to 200, like twice as big. And then the other direction, my pressure, well, that first ordered pair, the pressure was down at 15, so I'm going to start at 0. I'm looking for a pressure of 200, so I'll go a little higher than that, up to 250. And we'll take a look at the graph and see what we got. So there's my 200 line, and here is my line explaining the pressure. So we see it starts out very small, and then because it's exponential, it gets this curve and it rises very quickly. So I have here a point that they meet, and I can find that using the intersect command. So second, trace, option 5, shows me y1, yes, that's my first curve, shows me y2, yes, that's my second curve, asks me to guess where they meet. So I'm moving over to, went a little far, and I'll hit enter. And it finds that point of intersection. So when the decibel level is at 120, the pressure level is at 200. So going back to my question, when the pressure on the ear reaches 200, physical damage can occur. What decibel level would this be? This would be a decibel level of 120. And we got that from a graph. This was our decibels, which went up to 200. This was our pressure, which went to 250. We had our line at 200. We had our decibel line coming up. This is the ordered pair. This is the ordered pair where they met. And that was 120, 200 as that ordered pair. And so in this problem, we started by recognizing that a percentage increase right here would mean that it is exponential. The increase would mean that it's growth, so we found our growth factor. We used the ordered pair that they gave us to find the starting amount and to find our exponential model. And then we use a crossing graph method to solve for an ordered pair on that exponential model.